So a relation is a collection of ordered pairs, and we saw that already on the table. The collection that we had is the ordered pairs that we produced and we connected the dots. In general, that's what a relation is. A domain is the collection of the relation's first coordinates. A range is the collection of the relation's second coordinates. I'm going to use blue and yellow to color code the rest of this section. Every time you see blue, that means it's an element in the domain, or it has to do with the domain, and yellow has to do with the range. So you can see here 4 and 3, domain, range, domain, range, domain, range. I've collected all the y values here in the range and all the x values here in the domain. The instructions say shade the domain on the x-axis and shade the range on the y-axis. We can write that the domain is all x such that they satisfy this condition. -5 is less than or equal to x is less than or equal to 3. And you can see the domain right here, from -5 all the way up to +3. The range is going to be all the y values that satisfy this other condition, that the fact that they go between -3 and +2. You can see that here. They go from -3 all the way up to +2. Here, the domain is all x such that they go from -5 is less than or equal to x is less than or equal to +5. The y values span -4 to +5. Now you might say, Bergman, what does all this mean? Right here, what is this line? What it's saying is that it's creating a rule. This is the collection, the set of all x values such that they satisfy this condition. So if your x value satisfies this condition, then it can be in the collection and it can be inside the set of all numbers. Here at 13, I want you to try number 13. Do it exactly the way we did the previous two. The collection of all x values, it's almost every single x value is represented here. Except for one of them, there's a break in the graph right in the middle. Right here, all x values are represented except for the x value of 0. The domain is all x such that x is not equal to 0. The range is all y values, similarly, all that are not equal to 0.
By the way, I just wanted to say that as a quick fun fact, do you know that Honolulu is the capital of Hawaii? Have you been there? I've been there. It's awesome. You should go. Check it out. Honolulu is the capital of Hawaii, and that's your audio check.
Here, maybe you can't see it in the graph, but this graph does go as high as you want and as low as you want if you keep on following out. So we can say that this graph has a range of all real numbers. This is the symbol for all real numbers. All real numbers. The way you draw this symbol is it's basically an R with an additional vertical line right next to it. Now what about the domain? What x values are represented on this graph? Well, none of them that are negative values, and even between 0 and 1 there's no values there. It's because this is the graph of the equation y equals x minus 1, or maybe we'll just call it plus or minus x minus 1. So really, when we're looking at this particular graph, although you and I know how to take the square root of a negative number, we don't really have a place to put imaginary numbers on this graph. So we have to consider all real numbers to be our solutions, and only real number solutions, no imaginaries. If that's the case, then we have to make sure that what's inside the parentheses does not go negative. X minus 1 has got to be greater than or equal to 0. It can be equal to 0 because the square root of 0 is 0, and that's fine. But if it gets negative, then that's where we go into imaginary land, which we can't graph right now. It's just real numbers that we're graphing. So we're going to add 1 to both sides to get x is greater than or equal to 1. And so the domain is going to be all x such that x is greater than or equal to 1. We can see that graphically here also. It's allowed to be 1 right here, and then any values that are greater as well. So in short, be careful whenever you have a fraction that could have a 0 in the denominator or a negative in the square root. That's when the domain gets restricted. All right, kiddies, it's play at home time with Desmos. What that means is when I do something on Desmos, you do it too. Make sure you can show me your saved Desmos graphs when you arrive in class tomorrow. I'd like you to begin 3A, so that means copy the problem list and do the first problem.